Welcome back Year 12 to Term 2. Today I'd like to talk to you about the second assessment task that you'll be doing. Now this replaces the assessment task that you're going to do at the end of Term 1. Important things to look at is that it's sent out today on Monday the 27th of April, and the due date is not until week 4 on Monday the 18th of May at 3 p.m. Now the way in which you're going to hand that assignment in will depend on whether you're back at school, but hopefully by then you'll be able to physically hand in the assignment. Important to note that the weighting of this is 30%. In case some of you are wondering why we're still doing an assignment and you could still do the test, is that one of your assessment tasks needs to be an assignment. So we're going to make it the next assessment task, but this replaces the last assessment task that you were going to do in week 10 of last term. Okay, so you can read through the outcomes there, but I'll just scroll down to the actual assessment task itself. So it says down the bottom here that you'll have 3 weeks to complete the assignment, and that you'll be doing rates and ratios, investments, depreciation and trigonometry within this assignment. I'll let you read through the rest of that in your own time, but I'll just scroll down to the actual assignment itself. Okay, so quite importantly, you'll need to read through this part of the assignment quite carefully before you start doing the 9 questions which are below here. And look at this diagram. So when I'm reading through this outline, I'll refer to the diagram here, which is pretty important. So just quickly, and hopefully you've downloaded this assignment and you can follow along. Hopefully you can read this on here. But below is a scenario of a farmer who wishes to fence his property into 4 triangular fields. To complete this assignment, you will need to read through the information and complete the questions which follow on from this scenario. So here is a scenario with the diagram below. So I'll just bring this up a little bit. So I'm now going to read through the scenario, referring to this diagram here, and then I'll go through the questions which are the 9 questions which are below. So the scenario is, a farmer has a large field which he wishes to divide into 4 smaller fields. Each of the 4 new fields will be in the shape of a triangle. So you can see the 4 triangles here below. To do this, the farmer has decided to use a radial survey where the combined lengths of the 4 new fields from the central starting point add up to 2,000 metres. Now what that means is that length there, plus that length there, that length there, and that length there will add up to 2,000 metres. And on the side here it says A plus B plus C plus D equals 2,000 metres. You choose your own lengths. I'll come back to that in a minute. Reading on, an example of this new configuration is shown below. So this is an example of what you will do. Please note that the dotted lines represent the new perimeter fence. So these will be the new perimeter fence. You will need trigonometry to determine these lengths. So once you've drawn your diagrams, you will need to use trigonometry to work out your 4 new lengths. Also note that you are to create your own angles which are different to those shown in the diagram below. So in our diagram, we'll start at 0 and then we've gone 60 degrees. I'll just scroll up a little bit because I'll just go up a little bit. In our diagram, in our example diagram, we started at 0, then we had one at 60 degrees, then 155, the next one at 245, and then going back to 0. Just remember when you're doing a radial survey that this angle in here is obviously 60, but this angle here is not 155. This angle here is 155 minus 60, so what's that, 95 degrees. This angle over here is not 245, it is 245, take away 155, so what's that, 90 degrees in there. So you need to think about this when you're doing it. Okay, there's a video attached to this notification which has myself explaining all 9 questions. So there are 9 questions in total which you would need to complete, as well as direction towards the marking criteria which I'll talk about at the end. So if you've got any questions about this assignment, please direct your questions to this assignment to your teacher, whoever your teacher is, using the Google Classroom so everyone can see the questions you ask, so anyone can see any important information. All right, so I'm now going to go through the 9 questions which are related to this diagram. Before I start, I'll just go over the key things so far. What you have to do is create a field diagram that starts from the center, goes up to 0, has 4 lengths coming out that total 2,000. So you might have 200, 800, 600, 4 numbers that add up to 2,000, and then come up with 4 radial survey compass directions, not the same as we've got here. So you might have 50 degrees, 130 degrees. I'll leave it up to you, but everybody should have a different lengths and different radial survey compass degrees. Scrolling down, let's go through the questions that you have to do. So question 1. Now, at the end in the marking criteria, it tells you the value of each of these questions and how you can get full marks for each question. Some questions are worth more than others because some questions are more difficult. Here is question 1. Draw your radial survey with bearings that start from north, like it was in the diagram, and have 4 lines from the central point of different lengths. So they can't be all 500. You can't just have 500, 500, 500, 500. Don't make your life difficult by having 27 and really obscure lengths. The total of the lines, your diagram must include the following. Okay, so it must include a scale of 1 centimetre to 10,000 centimetres. Now obviously that doesn't make a lot of sense in your mind. So 1 centimetre to 10,000 centimetres. You need to change that back to 1 centimetre equals how many metres? So just saying that again, I don't want to give it away, but this means 1 centimetre equals 10,000 centimetres. You want to change that to 1 centimetre equals how many metres? You can change from centimetres to metres. So think about this before you start. Your diagram should fit nicely on a page, so think about that dimension there. So that's a scale question. Secondly, diagram must be accurate with all 4 radial points measured with a protractor. So in the diagram above, that had 4 radial points and they were measured with a protractor. It should look a little bit like the diagram above. The diagram must be labelled with the bearings and the 4 protruding lengths from the centre. So there, if I just scroll back up, the protruding lengths are referred to the bold lines here. That's 1 protruding length, 2, 3, 4. Remember, these need to add up to 2,000. Let's go back up. Label the lengths of the new perimeter fencing after you've completed question 2. These lengths will be rounded to the nearest metre. What it means by that is the dotted lines on the outside, you'll have to work out the lengths in question 2. So question 2, when I get to that, will ask you to find the new perimeter length. So the outside is the perimeter and these are the protruding lengths. Okay, so that's question 1. You can look at how much question 1 is worth in the marking criteria and have a look at what you need to do to get full marks in question 1. So, okay, just with question 1, I've just made a little note to myself here that exercise 1G, page 27, would be useful in helping you to do this because that refers to radial surveys. So if you're a bit unsure about radial surveys, 1G, page 27, will give you some help on how to do a radial survey. Okay, I'll write that out. Going down to question 2. Okay, so after you've done question 1, you can go down to question 2. Before I go on, just a reminder that although you should have all different lengths to your friends and different radial bearings to your friends, most of your answers from questions 1 through to 9 should be fairly similar to each other. So if you're trying to check, am I on the right track? You can ask your friends the answers they got, the work they did, and if your answers are fairly similar to each other, not exactly the same because they should be different, then you know you're on the right track. But if one of your friends has an area or a distance or anything like that that's way outside, double, triple, 10 times what you've got, then one of you must have made a mistake. All the answers throughout the 9 questions, you should all end up with answers within about 10% of each other. All right, so question 2. The farmer is going to put a barbed wire fence around the total length of this field. Okay, so from the diagram above, except for a 2-metre wide gate on each of the 4 protruding sides from the centre, plus 1 gate on the perimeter fencing. I'll explain that again in a second, but if the barbed wire fencing costs $7.40 per metre and each 2-metre gate costs $105, find the total cost of fencing the field. Your calculations must include the following. Now remember, I'll go through this gate scenario in a second, but your calculations must include the following. Trigonometric calculations to determine the lengths of the 4 new perimeter fencings, that's the dotted lines. The total cost must include the 2,000 metres of fencing that protrudes from the central starting point. Remember to subtract the lengths of the 5 gates which will not require barbed wire, and include the cost of the 5 gates in your total price. Now, that's a lot to take in. I'll try to explain that with the diagram above. I'll talk about these 2-metre gates on here. So you've got 5 in total. Okay, so I'll just scroll back up and I'll try to explain question 2 using the diagram. So what it's saying is, what you have to do is work out the cost of fencing. So you've got your 2,000 metres of fencing. You've got your new lengths here, which you'll have to use trigonometry to find. So altogether, you've got all these lengths here, plus your 2,000 metres here. And with reference to the gates, there are 5 2-metre gates. It doesn't matter where they are, but from the question saying, like, there's one here, 1, 2, 3, 4. So there's 4 gates there and 1 on the outside. Doesn't matter where. Let's say that's your 5 gates. So you'd have to subtract the 5 2-metre lengths of wire, so that's 10 metres of wire that you don't need to do. When you're doing your diagram, it'll be difficult to show 2-metre gates on here using the scale. So if you want to show the gates on your diagram, just put some little marks. The gates will be too difficult to draw to scale because they'll be too small on the diagram. But I just put them in random spots, 1, 2, 3, 4, so they can get to each field and into 5. So just going over question 2 again, you need to find the outside lengths using trigonometry. In question 2, to use trigonometry, you'd need exercise, actually I'll just scroll down. Well, to find these lengths here, you need trigonometry, and I'm not going to tell you which one it is, the sine or the cosine rule, but once you work out which one it is, it's either going to be exercise 4F or it's going to be exercise 4G. One is the sine rule, one is the cosine rule. You'll have to think about, how do I find this length if I know these lengths and an angle? You'd have to think, is that a sine rule or a cosine rule? Once you work it out, you'll probably see that's the same exercise or the same rule for all 4 sides. So I'll leave that one with you, and you can talk to your friends about whether it's a sine or cosine rule question. Any questions about question 2, please put them on Google Classroom and ask your teacher. So question 2 looks pretty confusing. You may have to read it a few times, listen to the video a few times, but you should be able to work your way through it. Okay, so you then go on to question 3. Just before I read question 3, if you make a mistake anywhere, if you made a mistake in question 1 or a mistake in question 2, obviously the rest of your answers will be out. But if you made a mistake in question 2, you won't lose marks in question 3 if you carry that mistake forward. So you'll be penalised in here if you made a mistake with your perimeter and your costing, but we would use question 2 answer to work out question 3. So you won't get penalised all the way through, but you should always check with your friends and your teachers whether you're on the right track. Anyway, question 3. Calculate the total area of the 4 new fields to the nearest square metre. Convert your answer to hectares and give your answer to 2 decimal places. This should be easier than question 2. Question 2 is a bit of a mouthful, might take you a little bit of time, but question 3 is not so hard to understand. You've got to find the total area of the 4 new fields. So if I scroll back up to show you what I mean by that, here are your 4 new fields, 1, 2, 3, 4. How do you find the area of triangles? Well, my clue is the question 3 is exercise 4E, exercise 4E, page, where are we now? Page 166. Okay, so if you look at that, that will remind you of how to find the area of four fields, area of a triangle, I should say. Now remember,